Hi, welcome to Building SaaS with Python and Django. My name is Matt Lehman, and normally on the stream we work on Python and Django. Tonight we're not going to do that. Tonight we're going to continue on a series of exploration with the Go standard library to see what's possible for building web apps using just Go for its standard library. And the reason I'm doing that is because I've got a presentation next week that I'm giving at a local meetup, and I'm using this stream as an opportunity to do this research live, learning together. It's a bunch of stuff that I have not been super exposed to. I have some basic ideas of what things I should go after and look into, but have not really dedicated a ton of time researching the Go standard library. So that's what we're going to do this evening, is continue on that path. And as you can see here, I've got a sticky note that we've got on the top here that's showing us the things that we can kind of cover today. That I said last time that we would continue on as the way to wrap up this series. So next week I should be back to my normal stuff, working on my software as a service in Python. This has just been like a good break for this month while I've been trying to prepare for this. But it's been hopefully an educational diversion. Certainly has been educational for me, which was part of the benefit. So we'll continue on this. We have 3 things that I really want to cover this evening and see how far we get. One is the topic of middleware and how we can insert that into a standard server here with Go. And then I want to be able to talk about setting context on a request and using that as sort of a data storage for the request lifecycle. It's typically, from what I understand about Go, is that you don't want to use a lot of data on here, but if there is kind of global data that you're going to be using for virtually every request. And the most common or the most obvious example of that to me would be authentication. So if you are dealing with users and you want to be able to tell who is who, then you could use authentication, and you could put in some middleware to help determine who they are. And then further on in the chain of requests, make a decision about who they are and decide whether they can access something or not. So I want to explore, can we fake authentication with some middleware? And then could we have a second middleware that kind of works in tandem to help protect a set of routes on the server that we have? And just to explore, like, what would it look like to have like an admin section of your website or something along those lines. So that's the plan. Let's do it. Let's see how that goes. And then finally, I think I commented on the last couple of streams, we did look briefly into what is available in terms of like data storage. So far we've seen routing, so having different routes and then all sorts of dynamic nature of them. We've explored templates. We've looked at the ability to handle static files and talked about the cool embed feature that's available. Actually, there's probably an update on that I can talk about. I have a sneeze that wants to come out, but not going to. It'll be sudden, I promise. Apologies. Excuse me. Anyway, the thing that we still need to do, whoops, I got rid of the thing that I had highlighted, is find some way to store data. And I talked about different ways that we could do this. We could talk to other APIs and have an HTTP client. I'm not going to explore that today. There's also the possibility of using some kind of flat files. So if you had data stored in already prepared JSON files or CSV that you wanted to parse, there's probably ways to do that. But sadly, when I looked at what's available from like an actual relational database, nothing seems to be included. So I know the goal of this was to explore what's available into the standard library, but I want to explore that maybe one step beyond that. If I'm going to accept one extra package, what would it be? And there's a couple of different databases I have in mind. One would be to use SQLite 3. The other would be a database that is called, oh shoot, I had it. What was it called? I think I left it in the README. BoltDB, which is like an in-memory. My understanding is it's a data storage that is kind of a key value storage in Go. I don't know if it has persistence. I have no idea. I don't know anything about it. So it would be fun to explore that because I've heard about it before. And then I asked the question, is there a database driver for CSV files? You could treat a CSV as a database. I don't know. Maybe, maybe not. So we'll poke around with some data options as things to explore. Okay, so let's get going. Middleware. I guess the first thing we need to do is bring up the Go documentation that we've been looking at. So there's a Go dev package, there's a net HTTP. Let's go back to this and see what is here. For the moment, we'll make this a little larger so we actually have an index that we can navigate through. But I think the thing that we're looking for is something that satisfies the particular interface that serves requests. And I want to say, I thought it would be in the types list here, but maybe it's, I don't know. I'm not used to looking at a lot of the Go documentation, so it's not obviously showing up where I would expect it to be. Maybe it's just an interface. Where are those? Oh, phooey. I think it's called serve HTTP, I want to say. All right, let's search for interface. Interface. All right, let's come back over here. Because the new serve mux, okay. New serve mux is like our router. And it's actually a mux if we're using Go terminology, but you can think of it as a router. So let's search for that. New serve mux. And it expects a, it can call a handle. And here is the handler. Ah, there it is. Okay, that's why I wasn't getting it. Where is this? So it's under. It is under types. I was just looking for the wrong thing. So the function that is expected to be on this interface is called serve HTTP. So I was looking for a type named that, but that's actually not the name. So I think what we want to do is make some kind of middleware that implements this method, and then we can hook that into our particular, like a stack of things. And I want to say, I'm trying to remember the best way to do this. Like, you can have, well, let's look it up, because it might be right. Yeah, let's talk about this. So the router itself, this new serve mux, is this thing follows the handler interface. It's a serve mux, but if you got down to it, it has this, I'm pretty sure it has this serve HTTP function on it, on that mux interface. In fact, let's see if we can use the LSP to help us out. So if we got a serve mux, how can we go to the definition of that? Go to the definition. Okay, so serve mux, and see if there's a serve HTTP with serve mux. There is. So we have this this receiver method, and I guess Go is kind of interesting that you don't have to tell it you're going to implement a whole interface very explicitly. Some languages would say like, my class implements this. It's like thinking Java. Class foo implements whatever. With Go, it's more like, you just have the methods there, and then it can figure it out. So the fact that this this method exists that is serve HTTP on the serve mux type means that it satisfies the handler interface. So we know that that's what happens. So I think what happens is, if we come back to our code here, where we've got the server, the handler is expected to be some kind of HTTP handler. And the way middleware works is it's kind of like layers of an onion, where the middleware is going to wrap around the handler thing. So you can add in and basically ensure that this code is going to be called no matter what. And so the job of a middleware is to return a function that does this sort of stuff, and then calls the next thing and treats it like you can think of it like links in a chain, kind of. I don't know if that's a perfect analogy, but it's sort of how it's often expressed. Okay, so when we add our our auth middleware here, we would wrap this probably and put it around this router. So the router is implementing the handler interface, and we would call something ourselves. So let's see how we can manage that. And maybe ChatGPT is probably, rather than waste my time trying to poke through a bunch of stuff, let's bring that back up. It's been a useful, I know the idea, and I don't want to fumble through the mechanics of setting that up, because I think that's boring for you and boring for me, frankly. So let's get logged in. I got to put on, I thought it was logged in, so hold on. I'm going to switch over to my secret screen. I'm going to hit the login button. I've got to log in with one password. So bear with me just a moment. So there's OpenAI, plug in that address or the email address and the password, and it's going to dump me back to ChatGPT here in a minute. Okay, I can now bring this back up. All right, so let's just start a new chat topic here. So we'll say in Go, please show the pattern to implement HTTP middleware with the handler interface. So it was key that we knew some critical words there. So we want to, okay, yeah, that's what I thought. So over in our code section here, we want to have, we're going to call ours auth middleware. But notice what it's doing. It's actually like returning it's wrapping this in handler func and then calling a function here. And then inside of this function, it's calling the next, it's receiving a handler and calling that handler's serve HTTP method. So that's where you get that wrapping aspect, where the function that we're going to return is going to be a valid handler, which can be plugged in over here on line 74. But internally, when its serve HTTP function is called, which is what this function here will ultimately execute, it in turn calls the next serve HTTP. Okay, so let's start with just a handler that just, I don't know, prints out something. I mean, actually pretty similar to this. I'm not going to use the exact same thing because we're going to fake auth here in a minute. But let's make it. So we're going to make a func, and it's going to be, we'll call it auth middleware. And it should accept an HTTP handler, and it should return an HTTP handler. All right, cool. So the next thing we need is we need to do that return, and we want to call HTTP handle func, and we're going to give it a function that has the interface. So far, so good. Now, critically, and this is where, like, you can see there's like a closure thing happening here, where this inside function is going to take state from outside. That's how that's working and making that happen. So the core of it, if we wanted this to do absolutely nothing, we would just do this. We'd call next serve HTTP takes the writer and the reader, or the request, sorry. So that's it. In fact, let's start there, make sure it's working, and then we can build up to our layers. And the cool part about middleware is that you can have a bunch of these things kind of built together, composed in different ways. And we see this, I've got this over my Django apps. So in fact, let's take a minute, since I am mostly doing Python stuff, let's take a minute here to look at what this looks like a little bit in Django land instead. So let's jump over to Journal. And just so my LSP doesn't yell at me, let's activate the virtual environment and start this up. So if we jump over to the settings file and scroll down, you'll find this middleware list. So the difference between Go and Django is that Django is like expecting these middlewares to be at different import paths, and they all follow a particular interface. But what's happening, and then maybe this is a difference, is that Django is taking on this work for you, where you give the list of middleware, and you can still think of it like an onion. So the security middleware is going to be the outermost layer, and it's going to call the white noise middleware, and then call the session middleware and common, and so on and so on. And when it gets all the way down to the middle, after the waffle middleware, that's when it then calls your actual mux, if we're translating this to like Go terminology. In Python, this is where your URL routes are pattern matched, and they get handed off to your particular views. Is that right? I'm trying to think if the routing is happening before. It probably is actually happening before any of this stuff. So maybe not quite analogous. But what happens here, and what's different between the Go setup and this, is that in the Go universe, you're actually having these functions, and you have to like call them yourselves and build the chain. What happens with Django is when the application starts up, you look at the WSGI file. When it does this get the WSGI application, it builds up the chain. You can actually, I've got a whole chapter in my Understand Django book, which you're welcome to go read on my website for free. And it explores the startup process and shows how the chain is actually built together. So it's all of those middleware functions kind of combined. So it's the same concept between Go and Django. The API is a little different in terms of the Go version passes in a writer for handling the response and the request object. The middleware in Django is not that way. I'm not going to get into the interface of that tonight. That's not really the goal this evening. But conceptually, you can think of them as pretty similar things. So what we want to do now is we want to go down and have our auth middleware. In fact, let's actually, just so we have some evidence that everything's going to keep working, let's put a little format print line here so that we can see called the middleware. All right. So if we go down and then add this to our router and surround this, remember we've defined this so that it accepts a handler as its argument and returns a handler. So that the server still has something that does serve HTTP calls. So now if we come up here and go to our app, and I had this loaded up earlier, so it's starting the server. I'm going to refresh this page, and you can see it called the middleware. And we got a response over here, which means the inside stuff that was in what we had defined. Whoops, that's not that. That was in. It was up here. Yeah, right here is our first little handle func. Still did its thing and wrote that value out to the writer. Okay. So what would you do with the middleware? I mean, you could do lots of things. So like we saw in that list in Django. So first thing that Django does is says, look, we will encase your app in a shell of basic security checks. It's pretty convenient. So what that's going to do is it looks for the presence of certain HTTP headers. It does various redirects. If you have certain settings enabled, like let's say your app is not behind a load balancer of any kind or a reverse proxy, and so you are expecting your app to actually do HTTPS connections, and you never want them to be insecure, actually HTTP. So one of the settings in the security middleware in Django says, if I ever see anything that's just plain HTTP, I will immediately do a redirect to the same URL, but with an HTTPS version. So it's got some protections like that in there that are trying to make sure that you're safe and sound. So you could do security stuff. You could do something like file handling. In this case, we saw how easy file handling was with Go. So I don't know that we do that. In fact, oh, this was cool. Let me actually go back. So I found out more about static. So we did this last time. where we had a static file thing. We created we used the Go embed package, and it read files that we were embedding right in our stuff, and then we wired it up this way. And I thought that was actually pretty clever, but what I found was even cooler was there's actually like an already built-in file system ability. So if we go, instead of going to net HTTP, or was it here? Hold on, might be here. FS. Yeah. It was this thing. So you can do essentially like what I did here with this route of get static. You can kind of do all in one step if you want. You can see sort of the example here where you do a handle, you give it the path, and then you say the actual file, because the embed thing that we were using is essentially a file system interface, and so you can do that yourself. I'm not gonna change my implementation here today, but I thought that like man, this is so cool. We did all this cool embed stuff, and we were pulling out this path value and building it ourselves, but none of that is necessary because the file system knows how to do that itself as long as you give this path. So check that out in the future if you're interested, if you want to simplify your static file handling and you followed me from last time. Pretty cool. Okay, so we've got a middleware. What could we do with it? I've said a couple things that Django already did. Actually, let's bring that up. Let's up one more time. It's an easy reference if I see it that way. Settings, middleware, middle. All right, so you can do security stuff. You can do static file stuff, although you don't have to. This is the session middleware. So Django has this concept of sessions which can be of a variety of types. You can have a session that is backed by a database, or a session that is powered by a cookie, or you can have a session that's powered by a cache system if you have like a Redis equivalent in your setup. And sessions were like a really weird concept to me for a long time. I didn't really understand what it was, but the idea of a session is just like, we're going to keep some state about a user who's visiting the site, and we're going to store it somewhere. That's really all it is. So if you've never heard that term before, that is what a session is about. So the idea here is that, like, in the way that this has happened, at least with Django, I can't speak to every web framework, of course, but the way Django handles it is it sets a specific cookie that acts as an identifier. And on every request that comes in, it looks at that cookie and says, okay, do I have this particular identifier in my session table or cookie store, whatever, however you've chosen to store it, it pulls that out. And that session could be some kind of authentication information. It could be an ID. It could be something. There are ways that you can make sure that this is not tamperable. It's in like a security layer. So you can have some confidence that the person who's responding with this did so in a pretty above board kind of fashion. So you can get the session, and this is where you would deal with like authentication. So if you had, you can think of it like here, maybe if you had nothing in your session data, eventually it would come down here and you get to an authentication layer, and the authentication layer would say, like, look for some valid session data that's been put in there about the authenticated user, about like who was this user, what's their ID, how did they log in? Let's check and make sure they have a valid login. Or if none of that information is present, then you can give them not 401. What's the challenge? What's the HTTP challenge? Is it 403? No, maybe it is 401. What? HTTP 401 status. Unauthorized, yeah. So which would then like trigger redirects and stuff and maybe send you to a login page, something like that. So you can see how, and why do we reach for middleware? The middleware we use is for tends to be for kind of globally cross-cutting things that you want all of your routes to do in your web app. And because you don't want to be adding like every single view you have, or every single route function, handler function, do this, then do this, do this, if it's all going to be the same. So by keeping it together in one like layer cake thing, you can do a lot of stuff. Okay, so what can we do with our middleware? We could, if we're pretending that's authentication middleware, you could assume that it's looking up something from the initial request, maybe a cookie, and doing some kind of database call. So let's see, like steps would be, and we're not going to do all this because we don't have a database. We're missing a lot of stuff here that would actually make this valuable. So we can't do a lot of this. But pull something from the request. Wow, come on, Matt. Likely a cookie. Check that thing against the database. This is where you'd have to be careful. Like this stuff, anytime you're dealing with authentication, that sort of things, you need to watch out for what you're doing. It's a hard topic to get right. So maybe as much as I think the standard library is cool, like this might be a case where you want to assess what's out there in terms of security handling, that somebody has likely done this for you. I don't know off the top of my head. So we could check that the person is authenticated in the database. Here's where we want to say, so what we're going to do for this session is we are going to pretend, well, I'll be explicit for this streaming session, be really clear. We will pretend that we did the stuff above and have a valid user. Okay, so now we've got a valid user. Now what? So I think what I want to do is I want to be able to pass in, or I want to be able to take this and pass this information along to the chain. Like anything downstream of this, like closer to the actual routes that are going to handle whatever path was provided, I want them to be able to take action on this. So we will, the thing we want to do is put an ID, a user ID, into the requests context. Okay. And then once that's done, we can then pass in, we can pass that down to the next serve HTTP. And you're going to see how this is beneficial. Well, I'm not going to bury the lead. Let's talk about how this is going to be beneficial. So we're going to put this ID into the request context. And then what's going to happen is we're going to have a secondary middleware. And why not? I'll go ahead and create a second function here. And we'll call it authorize middleware. Maybe not the best name because auth is using, but will work with me. And the authorize middleware is, what is it going to do? It's going to expect an ID in the request. So this is why these things are going to be paired together. And let's see, if the ID is equal to 42, pretend that it's an admin user. Now this is like all fake, but the purpose here is not to like show you some highly polished, go use this code in production kind of setup. It's to prove to myself because there are API calls that I don't actually know how to do right off the top of my head. I think I know what they roughly are, but I'm not solid on them. But also to show you that, like, okay, you can pass along data between middleware. This is how you would use middleware. This is how you'd build it together, and use it in different kind of fashions. So that's that piece. So the first thing that let's do is let's figure out this part on the auth middleware. How do we get this ID that we want to put into the request? In fact, I think let's declare. I mean, I didn't cover a lot, but I covered enough of the concepts to say we've kind of covered middleware. So let's go back to our stuff here, and I want to find request, that type. So request has a context attached to it somewhere. Just don't know where. Like a method. Ooh, this might be one of the things that we use. There's like so the thing that we're trying to do is take the existing context, add a value to it, and then make a new request that has that new context. And context is like we don't really use it for this purpose heavily. It's more used for canceling and timeouts and stuff like that. So this is like where it's slightly abusing the maybe best use case for context, but it is also an understood and accepted pattern. So let's go back to ChatGPT here. Let's see, from an HTTP request, how can we add a value to the context? That's what we're searching for. Okay. Here we go. So it's like you create a totally new context. This is what I don't have a full comprehension of I think it's like a Russian nesting doll of contexts too, that you can kind of peel off layers and have different layers of context. I think that's how that works. We're going to say that we want to take the context that's already associated with the request, and we're going to create a new context that adds in some kind of key and value here. And then from what we then need to do is then take the request and make a new request with the new context. So it's like a double creation of request and context, which feels a little strange, but that's the API that's accessible. So the critical thing is this user key. What they have in this example is needs to be like unique to your app. Well, I mean, it's let me rephrase that. It's more like a global namespace thing. So if you have a third-party package that happens to use the same context key as you and stuff something into the request, you might be in for a bad time. So that's where you might be motivated to use something specific. Okay, so let's do this. Let's go to the app over here, and we're gonna pretend, and like I said, we're just gonna put in some stuff ourselves. We're not even going to accept something from somewhere. We're just going to assume that this code has happened and has figured it out and pulled out a value somewhere that's a string identifier of who the user is. And we want to have our I like that name. User key is probably a reasonable thing. It's gonna they have a type alias. Define a key type to avoid context key collisions. I guess. I don't know. that doesn't. I don't what. I wanted to say more about this. Let's see what it says. Please explain this. Okay, let's learn together, at least from what ChatGPT is, and we can go verify it against the docs. I think it's right, probably, because this would be a type that is localized to this particular Go package, which would help Go prevent collisions, probably. So in the Go snippet, the comment refers to a practice that helps prevent accidental key collisions when storing and retrieving values from a context. Why is this important? Context type in Go allows you to associate arbitrary key value pairs with a context, which is exactly what we're trying to do. These key value pairs are often used to pass request scope data, such as user information, through a series of functions. However, because context with value function uses keys to store and retrieve values, using simple types like string as keys can lead to unintentional collisions. For example, if two parts of your application use the same string key user, but for different purposes, one part of your code could accidentally overwrite or misinterpret the data intended for another. This can cause subtle bugs that are hard to trace. Yep. Okay. How does defining a custom key type help? By defining a custom key type, you can avoid these collisions. Here's how it works. You define a new type specifically for context keys. In this example, the context key string. So it's just basically making an alias if you're not familiar with the syntax. So saying this is the new type, but it's really going to be this. By using values of this custom type as keys, you ensure that even if two keys have the same string value of user, they are distinct because they are different types. I guess Go figures it out. Maybe in the binary tags or annotates them as different types. I'm not sure how that works. All right, so the custom type is distinct from the built-in string type. User key is a constant of this custom type. If both packages try to use context value user, they would interfere with each other. Oh, so how do we have to refer to it on the other side? I wonder if this is let's ask. With this custom type, how are we supposed to use the value function, or I guess it's a method, value method, to pull the right key? That makes sense. We have to refer to it with a constant. We have to use user key. Okay. But we do have to do a typecast here to get it out as a string if we want to actually use it that way. So, but that's not because of user key. That's just because I think it lets you store arbitrary values in there, like as an any kind of thing. Okay, cool, good enough. I feel confident about that. If you have any questions about that, drop something in the chat, and I will do my best to search more if we need to search more or whatever. So let's make our new type. We want type. Let's use the same thing. Context key, the string alias here. Now we want to have a const of a user key with a type of context key, and we want it to be equal to user. Cool. So the next thing we needed to do was to say context is a new variable that we want to say context with value, which is going to, I guess, takes, oh, come on. And context takes a parent context and then the key and the value. Okay. So we want to take the context from the request. We want to use our user key, and we want to put, here's where we're going to put in our value. Just pretend it's going to be 40, the string of 42. It's an ID. Okay. So now we've stuffed we've created this context that's has a new value attached to it. And this was where we would say, well, I guess we have some comments up there. Because I'm going to commit this code later and share it, and people are going to get confused, but I feel like the comments are good enough. So the next thing to do is we need to say, there it is, R. It has a with context. Let's go back to the request package and look at with context. Whoops, did not search for that properly. New request with context. Do we use that or just with context? New request with context. I don't want to do that. There's like an existing receiver. With context returns a shallow copy of R with its context changed to context. Okay. Provided context must be non-nil. That's fine. So over on our code, we say with context and provide DTX. Okay, so I think at this point, we've kind of implemented our auth middleware. It's maybe it's a mix between an auth middleware and a session middleware. And we'll say called the auth middleware. Called the auth middleware. That's good enough. So we'll run this, and this time, I guess, and rather than going back to the browser, let's leave the documentation up, and we'll just do curl localhost users map. Okay, called the auth middleware. Great. Okay, so now it's time to do the other half of this. What does a what am I trying to say? So instead of calling this authorized middleware, let's call this like the admin middleware. We're going to pretend, write this down. I'll give it a doc comment here. Admin middleware pretends to permit admin users. In this case, admin has an ID of 42. So that's the only person that would be allowed through. So functionally, like, this is going to be about as brainless as you might expect, where we're going to say user ID is equal to the request. What was, oh shoot, I already lost it. Request, wasn't it like request value? Oh, request context value, right? Request context value, where we get the user key. And we want to cast that to a string. That's Go's syntax for casting. Okay, so now we want to say if hey Spurs Football, welcome. This is actually a special session, So I'm doing a presentation at my local web technology meetup next month, and the topic is using Go standard library stuff to write web content. So I'm not actually building my actual Python and Django SaaS app tonight. We'll get back to that next week because, yeah, I'll be available next week. So we're really just exploring what's possible with Go and hopefully people are learning along the way. But good question. Thanks. I didn't mention that this is like, probably put that somewhere. Maybe I'll put it on that sticky note. So we're gonna have, let's do it this way as like a guard clause, and we'll do a return here. That might be enough, but it's it's a crappy experience. I think I want to figure out something else before we do that. So let me jot a note. Special session on Go. Oh, come on. Make it a tiny bit smaller so it fits. Okay, so that's what we're doing. So this will be, yeah, I'm not going to delete that until we're done. So now we've got our admin middleware that is looking for, you have to have user key 42. Now, when we run this, we're gonna simulate both having access and not having access by literally recompiling the code. I'm just going to change this value from 42 to like 43 or something, and we'll just rerun it and see the behavioral difference, because we're not gonna see anything otherwise. So we now need to put this somewhere, and so this is where having like multiple layers of handlers can be useful. So we showed 2 weeks ago, I guess, how you can have, in this case, I did it as like a versioning scheme of, you can make a version 2 thing here and have a separate handler. I think what we can do in this case is let's like set up a fake admin route, which is like a super secret path, and then we will protect it with the admin middleware, and then we will test the scenario where you are this ID versus you aren't this ID. So let's try that now. So let's call it we'll just call it the admin. It's going to be our admin mux. New serve mux, and it's going to have admin handle func of we'll call it like a dashboard or something. You know, a lot of dashboard apps or admin pages have some kind of dashboard, right? So we'll do a func here, and we will, it's getting in the way. Too low in the file. Move out of the way. There we go. So then we want to write, what do I want to write? We shall just write, just do, hold on, sorry y'all. I don't need to do a format print line. I can just call write, can't I? Yeah. We'll just write directly. W write, and we'll say a secret to everybody. Everybody but 42. Oh, right. Gotta be bytes or something. Secret. I know I could copy this better. Everybody but 42. And then delete this stuff. We're writing out. Oh, come on. Boo. Oh, I remember what it was. It was just like, call it like a function, right? Okay, there we go. So we've got our new admin mux, and you can imagine like you'd hang a bunch of admin kind of functionality off here to see how many new signups you had or read something out of the database. I don't know. But we need to hook that up. So we want to have router, and we want to handle admin. It's going to be under admin section. But we want to do HTTP strip prefix and strip off the admin portion so that it can actually match dashboard, I think. And then give it the actual mux. Okay. So that should be enough to get this going. If we call this now, we've got this running. Did it actually run? Yep. Okay. And then we can do over here, we can say, we should be able to say admin dashboard. And you get a secret to everybody. Cool. So at this point, we should be able to go, this is where we can incorporate our admin middleware. And in fact, I want to say, let's put in some additional evidence that we've got this going, called the admin middleware. Spurs Football, I'm looking at your comment there. Do I think the interface can be used for different func to invoke for user and admin separately? Yeah, I'm sure you could make like a higher order function that could generalize a pattern. So if you wanted some different, like maybe you want to provide in an admin or just a general like user middleware that is checking for certain conditions, and you pass in some kind of checker function that returns a Boolean value of whether they should be allowed or not based on some that like maybe accepts their ID and does some extra checking. Like you could think of pretty creative ways to go beyond what I'm presenting here. I'm presenting like the most simplified version of middleware just to give the basic concepts. Hopefully it's enough to see the through line. Okay, so we have our admin middleware. I've got some routing on, some logging on here. I'm going to add the admin middleware around the admin mux. So if we come back over here and we start this up again, we should now see when we do the curl request that it should go print out two different things. We still got through, and we got through the called through the auth middleware and went down to the admin middleware. And that proved right there that actually our admin middleware is behaving to the level where at least it's getting past this, right? Because it was able to print out this line. So we now have evidence that that's working. The next thing I want to do is I want to show like what happens if you don't go that route. Let's change this to 43. So we're going to pretend that we're now a different user coming in. We're doing it in a really crappy way by recompiling the app. Rather than actually changing who we are, we're changing the server, which is totally backwards. But we get nothing instead. Although you know what I don't know what happened is we got a curl from a curl here. All right, ChatGPT, come on quickly. I don't remember the what. Now I can't see here. Sticky note. I like the sticky note a little bit, but it's definitely gets in the way. What is the curl flag to show the HTTP status? What? Why do you have to put all that? Not what I want. Can I get the status and other information at the same time? Is there a debug option that dumps the status. They really want you to use this W value. That's crazy. All right, forget it. Let's do, instead of using curl, let's just bring up the dev tools. So now we're going to go over here and look at admin dashboard. Before I hit enter, let's go to the network tab. Hit enter, and you can see we still got a 200. So we're not writing the right status code for this dashboard. So let's go back to ChatGPT and say in the Go response writer, how do I return a 403 status? That's forbidden, right? Okay, we got to call HTTP error with the writer. Okay. So here's where we would return early. That's important, but also take the writer and do HTTP error and give the writer. And I'm assuming forbidden here is like the actual text that they would see. And then we want HTTP forbidden. Okay. And how does this look? So coming back over here, let's clear this out, refresh. Now we get, why is it trying to do it? What? You guys are confused. Translate from Danish to English. No thanks. Okay. I don't know what that was about. So there's forbidden. I assume that the message is what we got here. Let's change this. Say nope. Let's see if that is what we expect it to be. And refresh. Nope. Okay. Cool. So that is how we get the right response. You can see how we're also not providing a favicon, so we're getting a 404. But the real request here was this one, where we're getting the 403. So we have effectively created with very little code, some kind of check that will do protection on certain pages if you wanted that, which is a really common use case for middlewares. You want to protect a set of stuff, and you have some like one chunk of code that you can be confident in. It's going to actually assume that is like, oh, what am I trying to say? Didn't say that very well. Sorry. You can have one chunk of code that you can check once and have confidence in it, rather than splitting it out in a bunch of places and getting it wrong. Okay. So I think that's enough exploration of middleware. I feel like that's also covers how to use request context. And I feel like the rest of this topic could be rather intensive. So let's take a switch gears into like data now. We've got and actually let me, before I do that, let's stop here. Let's commit this stuff. Add a middleware, and I'm going to use auth in quotes because no one would be crazy enough to do that, I hope. Auth example. Not in that. Sorry, that sounded like it was not sound code at all. The principle is sound. The implementation about how you surface the data to check, that the whole part that I said we're pretending on, that's the part that I don't want people to trust. And we'll push that up. And if you want to go look at this, you can. It is at this URL. You're welcome to clone that. Okay, so now now what? So we want to do what's going to be more interest. Well, they're both interesting to me. It's interesting to me because this is like definitely the tool I'd want to reach for this kind of app, especially at this like early stage. Have a SQLite database. You can get so far with SQLite, it's crazy. Especially if your project has no traction, like this is just going to be head and shoulders the easiest route for most things. But I've also heard about BoltDB, and I'm interested to see what its characteristics are. So what I want to do is go to, I think we've done this before, Awesome Go, where we found out that this was a separate package. And then I want to search for SQLite 3. The driver. I think this was the most common one, or this is the one that was listed. What I don't know, okay. Again, I'm trying to be very minimal with this code path. That has some trade-offs. Trade-offs are like, maybe you like object relational mappers. I certainly do, and I think they're great. There are Go ORMs. I'm sure they will be on that list. We can probably go back here and search for ORM, and yeah, there's probably a bunch of them. Gorm, like there's a whole list of them. Wow, there's even more than I anticipated. I do not know which one of these are good versus bad. This is one of the areas, like my work environment, we use SQL, but we use compiled SQL. We use like a SQL builder pattern where we're making our queries in like actual SQL statements and then generating, like doing code gen to create functions based on those statements. So it's very different from an ORM. So I can't actually comment on, are these good or bad? I have no idea. But the one that I have heard of all of them, that was this Gorm. Now, does that mean it's the best? No idea, but it's what I've heard of. But I don't want to explore ORMs tonight. I just want to see what can we do just having the database driver. How far does that take us? So let's check out the documentation and see what it does for us. That's not encouraging. They upgraded to V2 by accident. Okay. Let's start here. Go ahead and get SQLite, or the driver. We'll do go get SQLite 3. And it's probably going to pull. Oh, is it just the one? Oh, that's cool. We have one, and it's an indirect thing because we're not using it right now, but that would change. So you're Spurs. I'm looking at your comment here. Can we use stupid? I'm gonna put a junk comment in here because, like, I can't actually. Well, can I? Yeah, sure I can. See what it does here? It puts a heart icon or a little emote like thing. I can't see what word you wrote, which is so dumb. Whatever. So I'm gonna move that up by putting a little junk comment in there. Okay, there we go. Can we use both a middleware and an interface at the same time? I guess I don't. Maybe I don't understand your question. The middleware is an interface. So because the middleware returns an HTTP handler. So here's this thing. Okay, I think the key thing to recognize here is this handle func. in the way this middleware was created. Handle func takes a function that receives a response and a writer and a request, which is this inner function, and then it wraps that up into a handler that works with serves the serve HTTP interface. So what's coming out of here as the response is the interface. It's an interface that takes my code and like has packaged it up appropriately. So hopefully that helps clear that up for you. So we are using the middleware, but we're also using an interface. We're using both because the middleware ultimately is an interface. Okay, so we've done the go get on the SQLite driver, and I have just to be clear, I have never used this before. This is totally an exploration. I don't know what's possible. I don't know why they're immediately showing us some C code. This is bizarre to me. I want to see some not C code. I want to see some Go code that shows how to use this. So speak to me. Why? You can write your own extension module? No, I don't want to write an extension module. I want to use a SQL database. So we're gonna have to scroll through here because it's just giving a weird start. Or maybe it's because it wasn't expanded. I don't know. Maybe something funky just happened there because of how this is sized differently. So Go SQLite is a C Go package. It's written in C to actually interface with SQLite. However, after you have built and installed Go SQLite, you can build your app without relying on, we have to, great. So do we have GCC? I think I do for other purposes. Is that what's going to happen? Like, that's weird if you have to like compile with GCC in order to use SQLite with Go? Really? And I am willing to pull the escape hatch here if it's like if this is too hard. I don't want to spend like 2 hours on this. So I kind of want to see it work. You know what? Let's have ChatGPT try and summarize for us here. Please provide an example of using Go SQLite 3. Okay, so we use the database SQL interface. We have to import this with an underscore. Why? We're going to open we could use memory if we want to create an in-memory file. And I got a bunch of stuff in here. Now, some of the challenges, like they are showing some table creation stuff. So maybe we should do, because if we put this in memory and don't create an actual file, then we could execute this table creation statement every time and run this exec over and over again. I think otherwise, if we tried to run this once and then tried to run it, like stop the process and then tried to run it again, I think that it would blow up with a fatal error here, which we don't want. Okay, so let's try this. And I am going to attempt to leave off this import and just see what it does. Why not? So we're gonna go we're gonna go to our main, and let's put this, I guess, before. Where should we put this? Because we're gonna get a database as something returned, and then we would interact with that later. So let's make a little function, just because main's starting to get a little bloated. We'll call it createDB or something like that. And if it doesn't work, so the createDB function will like start it up in memory, create the table, and then return the DB handle. And then we can do some kind of, we'll plug that into one of these handle functions and try and put some data in or something. I don't know. We'll do an insert, and then we'll use a handle function that's going to take the DB. Can I do with a closure? I don't know. Okay. Still learning. We're just going through this together. So DB, create DB, like that. And so we want func create DB. And I guess to start, actually, let's have this be not used. Did that again. Not going to compile if we don't have this right. So let's just initially. Oh, we haven't given it a return value. Right. Okay. So here, we want a DB and an error. And we want to call SQL open. And I guess let's learn together what these are. I assume that the first argument is like a driver that you want to use, which is probably why you have to specify that import to the Go SQLite 3. Don't know. And then this next thing I am assuming is like the file name, but a thing in SQLite is if you use this particular file name of :memory:, it creates an in-memory database. And that's not like that's not a Go thing, that's a SQLite thing. And if error not equal nil, then we want to log fatal error. Okay, good enough. And then we do want to actually, what does this return? Okay, returns a SQLDB pointer. Got it. So SQLDB pointer, and we can return that if it worked. We're not actually using that, so we'll just call this for now. Okay, I predict this will blow up. If all goes according to plan, it should blow up. Yep. Unknown driver. Cool. So that was expected. So now we want to add this line, which it's weird. So this is the thing that's very strange to me, is that you have to, and I guess like on one hand I get it, like you have to tell Go I'm gonna use this thing, or this is where to look for some code, run some code here. But Go is often pretty much like, if you're not using it, you need to remove it. So it's this weird kind of conundrum. Let's see if this worked though. So does just including the import give you... Ooh. Well, that's interesting. It is just not going anywhere. What are you doing? So we're stuck with the halting problem. I don't know why it's hanging here. Okay. Maybe this was like a first time thing where it was doing some bootstrapping and compiling. Because that was ridiculously slow. If it did that all the time, that would just drive me nutty. All right, let's try again. See if it goes super fast. Okay, it was much faster that time. So perhaps it was a bootstrapping. This thing had never been compiled before, and so it was under the covers compiling. All right. So now we have, I guess, a database. That was pretty easy to add. We just had to bring in the import, and we've got the DB. We've got it in memory. So actually, like now, let's take. Oh, yep. We want to definitely. We do want to do this defer DB close. That's a good thing to do. Clean up after ourselves. And that will, I mean, since this is an in-memory database, that should tear down the, well, okay. It probably was going to tear it down either way. But I guess we can be a little bit better citizens, I suppose. So let's try and take this directly and copy it in there. Move it over. Yeah, gross. Okay. And we're doing an exec on that table with that SQL, that DDL, data definition language. That should create a table for us. So let's try running this. Still runs. Cool. So we have, in theory, a table. I want to insert. Let's insert the. Okay, so using the classic like Alice and Bob. So what we're gonna do, we're gonna insert this in here, and then we'll make a new like DB route that just pulls from the database and writes that out to the response. I'm not gonna. We've already done like JSON stuff previously. I don't feel like pulling that out in a structured way. Although it'd be interesting. I don't know what the rows are like, so maybe this will be easy. Maybe it'll be hard. I don't know. So let's take this insert and put Alice into the database. ChatGPT is pretty nice sometimes, especially for this. Guys, the stuff we're doing here is not super creative thinking, so it's fine. And it's teaching. Hopefully, it's teaching you. It's certainly teaching me about how the SQL interface works with Go. This is where I'm like, I much prefer to have an ORM. I don't really like mixing a bunch of SQL statements directly in code. It's okay, but not really my style. Okay, let's make sure that this still runs. I don't want to. One thing I learned in college was like, I had a project where I just wrote a ton of code. And this was a C++ project. It was on a crazy old version of Visual Studio, like not Visual Studio Code, that didn't exist. Like old school Microsoft Visual Studio. And I'd written all this code and was not testing regularly, not even trying to like compile regularly. And then when I finally did, and this was before I knew about version control, I had done like thousands of lines of code foolishly, and then tried to run it and nothing worked. and I didn't know why, and I didn't know how to get back to where I need to be. So it teaches you some lessons in life about how to write some stuff. Okay, so every time this runs, we're going to get a DB created. We're going to create this table. We're going to add Alice to the table. So now we should have a DB with at least that in it. So now what I want to be able to do is create a new function. We'll just put it right here because it's close. We'll call it router handle func, and whoops, handle func. Fine. And we'll say we'll just call it route DB. Keep it as simple as possible. Take a function, and here's where I want to take the DB instance and do the query. Now they're closing. This is, what is the close? Why are they deferring on the close? So they're just selecting. There's no where clause here. An update. Setting age. Okay, so they've got a prepared, these are essentially prepared statements where you've got the SQL and then you pass in the things that are going to be prepared for. So you're going to set the 31, and your where clause is going to put in Alice. Okay. So let's take this chunk of just looping code, and we'll just take it like this, copy it, and put it right inside the handle func. We need the database handle. We'll do that. So now this thing has a closure to get the database. There are probably other ways to build. Yeah, I'm sure there are other ways to build this. You could pull this out separately, but this will be fine. The thing that we want to do is, what's this doing? Okay. Scan. Okay, cool. Keep learning. Scan copies the columns in the current row into the values pointed at by destination. Okay. The number of values in destination must be the same as the number of columns in rows. All right. So keep doing that. So because our table has 3 in it. Whoops. 3 things: name, our ID, name, and age. And we are selecting all 3 from that table. So when we've got our rows here, and then when we loop over the rows with the iterator stuff here, we're going to get all 3 pieces. And this is where we can do, let's just change this to fprintf and put in the writer. That should work. So, and then we can get rid of this thing. I think that's it. Let's run this again. And now we can go to our curl and do db. We should get to Alice. Whoops. Empty reply. Failed to, oh. I see. Here's what we did. So here we thought, I thought I was being clever and using defer, but it left the function, and then it closed it. Because defer waits till the end of the function, and then as soon as the function exits, or as soon as the function returns, it runs whenever it was deferred. So really, what we need to do is put the defer here, outside of that function. So for the life of main, we will have this going. All right, try again. Cool. ID 1, name Alice, age 30. So that was pretty easy. And I mean, I think there's probably layers that I would add to this. So if you wanted to deal with an API, I think you'd be more likely to have some kind of code that wraps this up in, say, a repository pattern. A very common pattern where the idea with a repository pattern is your code, your main application, your main business logic in your app shouldn't have to know about where the data is stored. So the repository pattern, the intent is to abstract away where that data is stored. In this case, it's a SQLite 3 database. So what you would do is you would write some kind of repository that's a set of functions that allows you to do basic kind of CRUD operations, where it's creating, reading, updating, deleting, all that sort of stuff. And your repository would work with some sort of model that you would define. So we've got an example here where we're working like very directly with a users table here, but you could just as easily create a type that's let's say a user struct, right? And then have an ID, which is an int, and a name, which is a string, and an age, which is another int, right? And so when you're doing that style, your repository would, you would do something like get ID 1, which would be Alice in our database. And the repository's job would be to actually go do the query in the database, the actual select call. It would get the row out as we saw here down, because like doing it this way of working with the raw rows is probably not what you want to do. Would be my recommendation. I mean, you do what you want, but like this is really more exploratory than anything else. But if you had this wrapped up in a repository pattern, all of this stuff would hide away, and you would have code that would look like user repository or user repo, and then you'd say get and 1, and you'd get on the other side, you get the user back, and the user would be that user type we saw above. So if you wanted to get out the name, you would get out user.name, and so on and so on. So that would be how you can make it so that the rest of your code doesn't even need to know you have a database. It just knows that it interacts with the repository pattern. There's some benefits with that, is if you made that repository an interface and you injected this as you're building up your app, then you could, in theory, test your handler functions and put in a fake repository that's just like an in-memory database. So if you actually want to write tests and don't want to test with your SQL database, then you could do that. Now, I don't know if that's actually beneficial for SQLite, because SQLite in memory is so fast that you might as there's some argument to say don't do that. Like you're kind of doing overkill. Just use the SQLite database. So there's different schools of thought here. But that's databases at the most basic. It seems like a pretty reasonable process. It is sad to me that you have to, like, this driver is not included. It would be nice if at least this one was available out of the box, because it's so common. It's like, I mean, there are more SQLite databases on the planet than any other database combined. It's just crazy popular. So I've seen languages that choose to include SQLite 3, and I think it's a really great idea, great choice. All right, so let's clean up here. So the last things we need to do, we've got our app, we've seen some updates, and then we've got our Go mod file, but you see how it says it's indirect here? Well, it's no longer indirect, but the reason it still says indirect is because we haven't updated our module file. So if we do go mod tidy, then instead, I think what we'll see is that file now says it requires this, because it detected, it scanned through the imports and said like, okay, I've got this thing that I have to depend upon. So that's useful there. And now that we've added our first package, we also have a go sum file. So if we look at this file, it should be like the hashes or something of the actual package that we're using. Okay, and you'd commit both the go mod and the go sum file together. So that takes us to the end of the database exploration. Add DB exploration. That was cool. All right, I got probably about 30 minutes-ish left in the tank. Let's see what we can learn. So we've done SQLite. Let's learn about Bolt DB and see what it's all about. I'm pretty positive it's going to show up on this list. Bolt DB. Really? A simple and powerful toolkit for Bolt DB, but not Bolt DB? Well, that's bizarre. Guess maybe it's not that awesome, right? Joking. Okay, Bolt DB. Oh, is this called Bolt? Maybe that, okay, maybe it was in there and I just was looking for Bolt DB, expecting that was the name. Bolt, Bolt, B Bolt, Bolt, Bolt. Is this the same thing? B Bolt? Or is that something different? And okay, hold on. I want to get this right. Bolt DB. Bolt DB Bolt. What the heck is B Bolt? What? Maybe B Bolt is a fork of Bolt DB? Alright, I don't want to invest in something that's like not used. And this guy, I'm aware of Ben Johnson. He's got some good packages. Maybe, yeah, like right now he's working on Lightstream and LightFS. Well, maybe ChatGPT has enough history because it looks like it's been archived for a while. Why is Bolt DB archived on GitHub? Did Ben Johnson provide a reason for doing that? Is the project dead? Is there a replacement? Okay. It's too popular, so he gave it up. He didn't have the time. Still used, but that makes me nervous though. It's like, if so maybe this B-Bolt thing. Okay, a fork named B-Bolt is a drop-in replacement maintained by the community. Well, that's encouraging, I guess. Before we look at B-Bolt, are there other popular Go alternatives to Bolt DB that gained popularity after the project was archived? BadgerDB, B-Bolt, that's like the closest thing. LevelDB by Google. RocksDB by Facebook. NutsDB. Ooh, okay. Let's look a little bit more at the level DB versus RocksDB thing. That's interesting. Level DB. It's written in C++. That doesn't not necessarily strike against it, but I thought it was a Go thing. Not a SQL database. Only a single process can access it. CMake. Okay, I don't. No way. I'm not using something that's a C project. The whole point of this is simplicity. Like, no. What? Come on, ChatGPT, you failed. Are you seriously telling me that Go level DB? Oh. So, like, somebody took the level DB concept and made a Go version? So not nearly as popular. And hasn't been touched in 2 years. But this that's the frustrating thing with like open source sometimes is like just because something hasn't been touched doesn't mean, I mean, I guess there are plenty of issues. So what does this mean? Does it mean this person is left this project to be dead? Does it mean that they think it's done? I don't know. Okay, let's say that that's not the one we want to look at. And it's definitely not this one because this is a totally different language. It's not even Go. So forget that. This one also may be a different language. RocksDB looks like it's got a Go RocksDB. So that doesn't sound right either. RocksDB. What language are you written in? Also C++. Well. And its latest build says failed. Not encouraging. So it is a derivative of level DB. Looks like it. I mean, it may be awesome. I just don't have any interest in doing that. Check out the website for a minute. Okay. No. No thanks. So those are the two from the big boys, Google and Facebook. Let's check out Badger. All right, you're actually written in Go. Well, that's a step up. Pretty popular. Okay, get rid of this, get rid of this, and get rid of that. So this one's also pretty popular. It says 8,000 stars. It says 13,000 stars. Okay. Okay, I want to see. What do I want to see? There's got to be. How many dependencies? This is interesting. Okay, how many dependencies does this have? This takes on itself 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dependencies. How about Volt? How many dependencies do you have? Much fewer. 1, 2, 3, 4, 5, 6. All right, so if you're going for like minimalism, I guess Bolt is more minimal than Badger. So this is like archived. So we want to look at Badger or B-Bolt. What's the difference between them? Oh, stop autocorrecting my stuff. It is the underlying base for database for dgraph. I've heard of dgraph before. What do they do? Join those who left joins behind. Oh, it's a graph database. Oh, okay. I thought that we were just looking at like key value databases. So this is a very different type of database, which may be cool. I don't know if that's what we want though. Well, then look what it says though. It says that it is a fast key value DB in Go. Oh, so maybe dgraph is the graph database that is built on top of Badger, showing that your entire business can basically just be a hash table, glorified hash table. Okay, let's read. Embeddable, persistent, and fast key value database. dgraph is the distributed graph database, meant to be a performant alternative to non-Go based key value stores like RocksDB. Right. Seems pretty solid, or it has a solid heritage, I'll say. When I see somebody who's running Jepsen, if you are not familiar with Jepsen, Jepsen is like a very rigorous, it's like one guy, but he runs some like crazy tests against databases and finds all sorts of problems in databases. So anybody who claims that they have a database, he's like, nope, you don't. Like, I'm gonna prove that your stuff doesn't actually work the way you think it does. Pretty wild. It's a hard thing to get through. Now that doesn't say that they are passing all of the Jepsen suite, but the fact that they are aspiring to that with a nightly 8-hour test suite is saying a lot, I think. Okay, let's jump to the Badger documentation. Take a quick peek at it. I don't know that we're actually going to get... This will probably end the stream with like things that you can go look at. Let's like take a look at this. I am satisfied that we at least got some real database stuff embedded in this. But it's good to know what else is out here. So we'll spend a few minutes looking at Badger, and then we'll do a similar comparison with B-Bolt, see how they compare. And then you can decide yourself. Okay, top level in Badger is a database. It represents multiple files on disk in specific directories. Okay. So Badger is actually a directory that puts stuff in there. So it's kind of like, I guess that makes it kind of like a Git directory. So there's, the git.git folder acts as a database of sorts and has a lot of files in it. So it's a similar philosophy, perhaps, in that way. So they open the database. They apparently provide some options, and they close it. Feels very much like the SQL API that we used so far. They have an in-memory mode. That's cool. So if you just want like a pure cache while your process is running, seems like you can do that. You can encrypt stuff. Cool. So they have transactions on Key value store? Huh. It's hard to assess these at this kind of stage. Like what's truly valuable when you're looking at these, like what's the design decisions you need to really be weighing here. Maybe you can only really get a good feel for it by having some experience with this. I am surprised that, I don't know if maybe it's you always have to make a transaction. I feel like that'd be kind of clunky. Like you might get some better guarantees, but I don't know that I like it. When I think of key value stores, I don't typically think of transactions and dealing with that stuff. Oh man, getting into some real heady distributed theory stuff here. Merges and monotonically increasing. Okay, seems like pretty industrial weight tool, which is awesome if you need that. Cool. Another tool that you could probably reach for is Nats. Nats is another, it's not specifically designed to be a database, but it has a key value store in there. All right, so let's assume that Badger's like for more industrial purposes, which is very much not in the spirit of what I've been trying to do with use just the standard library. But they have different goals. That's cool. Like they're this company that's building Badger is also trying to be an open a graph database company. So they are attempting to make like a high scale graph database. So they need something industrial. But if you are working on like a small little SaaS project, it sounds like it's more than you might want. Again, not knocking it, don't have any experience with it, that's just my assessment of it after looking at it very briefly here. So let's take a look at bbolt and see how it compares. I'm going to get rid of the Facebook one here, and we'll say that we're done with the SQLite package as well. So let's go to bbolt and look at the documentation for bbolt, see how it compares. bbolt is a fork of Ben Johnson's Bolt. It's got a community, improve reliability and stability, bug fixes, performance enhancements. Bolt is a pure Go. Oh, what is LMDB? Huh. Lightning memory map database. Okay, so it in turn is built off of something else. Cool. I guess. Ultra fast, ultra compact, crash proof, key value, embedded data store. Huh. $32K. Well, okay. Oh, it's the data store that powers Open LDAP? What? Cool. Oh yeah, it says right there. Oh. Okay. Well, neat. The goal is to provide a simple, fast, and reliable project for data that don't require a full database server. Now, maybe why Ben abandoned this is because if you look at Ben Johnson's work these days, I had his account up earlier. He's looking at Lightstream and LightFS, which they are cool projects that build on SQLite 3. So Ben is like all in, seems to be all in on SQLite 3 as a tool. So maybe he's just decided that, hey, relational stuff is pretty awesome. And again, I'll say it again, the SQLite 3 is just this ridiculously powerful, versatile, ubiquitous database. That's like the most used database on the planet. It gets more testing than you can imagine. Like there's millions of lines of test code. It is just absurd in the way it's developed and the kind of rigors that is put through. So if you want to like have a single database, and if you had to pick one database for the rest of your life, I mean, it's not going to work for every project, but the one I would probably pick is SQLite 3, which is why I took the time to show that one first. All right, so we're going to say we are not going to look at any more at Badger. So let's take a quick peek at what bbolt looks like, because it might be the simplicity that you need. If it truly is you just need to have some keys and store some values, then perhaps that's even better than SQLite, because then at that level, you don't even need to create tables. You just stuff some data into a different key, and you literally treat it like a gigantic map. Wow, that coffee was very cold. Okay. Let's look through this. So same pattern. You open a database. Looks like this is a database file. And looks exactly like the SQL stuff we had. Fatal, if it doesn't open, you defer the close after that. File lock. Okay, so there is limitations about who can access it. I wonder if it's for readers though. So here's something powerful about SQLite. Is the way SQLite's designed is you can have lots of readers that are all accessing the same database. The limitation comes with writing, and even then, writing is not as limited as you might think. If you there's a different modes in which SQLite can operate. One of those modes, which is basically should be the default but can't for like historical legacy reasons, is called the write-ahead log. And this is well known. Like most projects that are using SQLite, if they're kind of packaging up themselves, they are probably doing the work to set the write-ahead log mode. And with that enabled and a few other settings, you can actually get quite a lot of even write performance out of that because of some trickery on how it manages that. So you can have tons of open readers to get a lot of read throughput on this, and then you can have a fair amount of writers as well to get some pretty consistent write performance. And on top of all that, it's a single file. It's just mind-boggling how powerful that system is. Anyway, let's continue. So this system sounds like you maybe cannot have multiple readers. I don't know how that works. Bolt only allows one read-write transaction at a time, but allows as many read-only transactions. Okay, so it is similar to SQLite in that regard, but I don't know why it would time out if you're opening it. That doesn't make sense to me. Maybe there's some like coordination. Maybe when it opens up, one of the readers that opens up has to like write to a spot saying like, I'm here and I'm watching this and I need to coordinate. I have no idea. I'm just totally speculating. Transactions are not thread safe. There's some definite limitations. So it's certainly meant for smaller projects. Creating a transaction from the database is thread safe. Huh. Okay. Transactions should not depend on each other. Okay. All right, so you still have to do some transaction stuff. That's similar to Badger. I thought that you'd have some kind of simplified interface where you could just set something and deal with the, last writer wins kind of scenario. So you can do read-only transactions. You can do updates. How did you get data? Like I didn't actually see. I see so they show how to open it. They show how to update it. There's a view here. Oh, is this like, this is where you'd actually view the data and do something? But then what's the error for? What's going on here? I don't know. Do stuff in a batch. Begin, rollback, cool. I don't know why they have a concept of buckets. I'm not sure what that's about. Save a key value pair to a bucket. Use bucket put. Transaction, bucket, put. Okay. Yeah, still seems harder than like the key value interfaces I'm used to in the past. Okay. I don't know that I want to explore this anymore. It looks like a fairly interesting project, but a little bit lower level than I even anticipated. I think the other thing I've seen, just for the sake of completeness, I've looked at Nats before, Nats.io, I think, website. I think that was the right one. Hopefully it didn't take us to a domain that's going to be embarrassing. No, that's the right one. Okay. So Nats does a lot of things, is written in Go, and has libraries for Go. It's not necessarily small though, but we were to bring up some of the pieces of Nats. Nats tools, is that it? No, looking for so Nats has a key value store tool. Jetstream. There it is. Okay. And let's see if we can get an example. The problem with this is that Nats requires a second process to be running. So you're really like communicating over a protocol, and they're doing something with a command line thing. There are Go examples somewhere. I don't remember where they are though, so I can't even show that off really well. Let's see if I can find it, and then we'll wrap up. Nats.io code examples. It's like a whole website. There it is. All right, here we go. Nats by example, Jetstream. There it is, key value. And we've got an example in Go here. So you essentially connect to Nats, and then you start putting values in. You say like, put this in, get it out, put it in, get it out, like update it. Put a timeout on it. Like it's a very simple, in my opinion, key value API. Maybe limited on like transactional safety and a bunch of stuff there, but if you're truly looking for like rudimentary key value capabilities, Nats could be pretty powerful for that. But like I said, the downside is you'd have to run this Nats server, which is a process that your program would then be talking to, which to me is like another argument for using SQLite 3. It's like SQLite it's so fast and it doesn't talk to anything else. And so SQLite, it has like stupid ideas in it that become possible because of how it's working in process. Very common example. Maybe you've heard of the N+1 query bug pattern. So the idea is this: like, I have my Django app. I have a Postgres database, and I do a query for a list of objects, a list of rows from the database over here. Okay, and I get that list, and then I'm in a template, and then I want to go iterate through that list, and I want to print out information one at a time. So that's one query. Okay, in that loop, there is some foreign key to a second table in the Postgres database, and then if I do the query wrong, every time my loop hits that foreign key, it does another query to the database to get that one row from that other table. And so the reason it's called an N+1 query bug is you do one query to get the first list of stuff, and then you do N queries for all of the other items. And because this is over a network, and there's latency between each one of those calls, that can add up very quickly. So if you can even think, like, if I have 100 items that I need to print out, if I am doing one call and let's say it takes, I don't know, 50 milliseconds or 100 milliseconds, and then I'm doing 100 calls that, so you're suddenly looking at what, 10 seconds or 10 seconds and 100 milliseconds just to get all of those different rows. Okay, so that's the scenario when you are working over two processes over a network. With SQLite, you could do that same thing. You could be in that same exact problem scenario, but now it's in memory. It's writing to a file or retrieving data from a file. So even if I wrote it inefficiently, where I'm doing the one call for the list of things, and then I'm looping through and getting a foreign key, and I need to go back to SQLite over and over again, because it is right there resident with the process, rather than it being 100 milliseconds for every call to the database. I was making that pretty extreme on purpose. It could instead be a small fraction of that time, like measured in milliseconds or microseconds, so that the performance of that bad behaving code is so quick that it was actually easier to write. Because the way you're supposed to solve that problem with the traditional client server pattern with your database is you're supposed to know in advance that, hey, I'm about to do a loop where I'm going to look up 100 other things all at once. So I want to do a join, because I want to do the first query where I get the list of objects, but I also want you to look ahead and see all of those foreign keys that is in that list of objects. I also need all of those, all of the related data there as well, and get it back as like two or one big request. But that's extra preparation, that's extra planning work on your part. It's knowledge that this problem could happen. And SQLite just was like, no, forget all that. We're just going to do it so quickly because it's right in the process. So that's what pushes me towards, like, SQLite is just this really amazing technology if you can use it. All right, I'm going to get off my soapbox for why that's cool. Nats is also a cool project, so check that out. So I think that really wraps us up for the evening on what we're going to do. What's left? Do we have any? Nope, we've already pushed that up. So we ended up not doing anything with Badger or Bolt. They both look like pretty cool technology, but they seem a bit more involved than I anticipated, which is fine. I didn't know what to expect, so that's all good. But that brings us to the end of where we are going with Go. I think next week, Wednesday, I will be presenting this at the WebTech Meetup. I'll probably actually record that session and put that up on my own YouTube channel as a distilled version, so it might actually be a little bit more polished, because this is, as you have seen from the last, I guess this is 3 weeks worth of stuff, and this code, while it works, is it's not super pretty. It's pretty much a mess. More like a scratch pad, right? But it gave us a chance to learn about different things with the Go standard library, and I feel like I've learned a lot on that journey. And who knows, maybe I'll make a future app that uses Go and to go quickly. So I'm going to end it there for the evening. Thank you for joining in. You can do me a favor and like, subscribe, comment, all of those good things. There's tons of ways you can support me on Patreon or here on YouTube if you want to subscribe. There is my website where I don't write a ton. I do write periodically, but I did write a book. And if you want to look at my book, and you can, man, it really just does not format well on this width of screen. I got to go fix my layout stuff apparently. But you can read this whole book online. Here's all of the content sections that are there. There's like 20 chapters worth of stuff. And if you like the book and you want to buy a copy, you can do that too. So I think that'll end it for this evening. Hopefully you learned something tonight. I'll catch you next time. Take care.